Massive cracks, sinking cities, and the landslide, this disaster doesn't happen overnight. They begins with tiny, invisible movements of Earth driven by shifting tectonic plates. Even the continents like Africa are slowly breaking apart. So the question is how we can track these moments in millimeter level accuracy. Today, uh, we are using 100 plus Sentinel-1 SAR images to uncover the deformation you can't see with your eyes. Before we dive into the actual tutorial, let's understand the theory at first. Okay, I have write some of its theory in my website. Okay, and you can also visit my website here, and these are my blogs. Okay, and this is the result that we are going to derive in this video. Okay, at first let's understand the theory. The synthetic aperture radar is an active microwave system that transmits the electromagnetic pulse and the record the backscatter signal. Right, its SAR pixel contain both amplitude and the phase information. The amplitude describe surface reflectivity, and the phase encodes the two-way time distance between the satellite and the target. Right, the interferometric phase between two SAR acquisition is computed through the complex conjugate multiplication and producing an interferogram whose phase components can be defined as this is the phase that we obtain from the interferogram. It is made from the phase difference between the two or the more sentinel imagery due to the deformation and due to the topography, due to the atmospheric error, and due to the orbital error, and due to the noise. And here in this tutorial we are using 100 plus satellite imagery to define eliminate all of the phase due to the topography and atmospheric error, orbital error, and the noise error, and we will only calculate the phase difference due to the deformation. And after the phase unwrapping, we get the actual displacement of the ground along the line of sight using this formula. Okay, and we are going to do this research in the Kathmandu, which is the capital city of the Nepal, and these are the actual methodology. Here we are going to do this analysis inside the NB-SAR escape. So these steps are based on the NB-SAR escape, and the actual same steps are followed in our tutorial. At first, our analysis workflow begin with the construction of the connection graph, define the interferometric network topology, and a master scene is selected to minimize the temporal and the perpendicular baseline relative to other acquisitions. As you know that the SAR data doesn't capture capture the imagery from exactly same points over the time. So we have to measure the perpendicular baseline distance between the two acquisition point, and we are only taking those scene who has minimum perpendicular distances. And after we completing the interferometric network topology, after the construction of the connection graph, we move to the first inversion step that estimates linear deformation velocity and the residual topographic error. And all these parameters are the principal parameters, and we can change after according to our requirement. And after that, the second step is started from the same data set. I will show you each and every step in the video, and then after we finally we geocode all the information, and we get the result something like that, and we get the color range from the minimum deformation to the maximum deformation. Okay, let's start. How? Go to your favorite browser and go for asf.alaska.edu to download the Sentinel imagery. And at first go to your area of the interest, and I am going to do the analysis over the Kathmandu region. So I am zooming over the Kathmandu here, and using the drawing toolbar, I am drawing the rectangle over here, and you can see the area of interest already, and data set is Sentinel-1, and I will select the start date and the end date. Here I am downloading the one imagery of 2026, and I am using the filter type that is L1 single SLC band and IW, and we leave the polarization here, and we use the descending orbit, and just there are 5 files, and just hit over the search. And I'm downloading only the descending data, because we cannot mix max the descending and the ascending orbit. So here I am zoom out over the Kathmandu to see the best data that is need for the analysis, and I just hit download button, and the download region is automatically get started after I log in. I am logging with my credential, and the download is the page is redirected to download, and yes, my download get started here. Okay, just wait for the some minute until the download is completed. Okay, go to the download section. Here you can see all of the download my download file here. We are not using the whole scene, we are using the only one scene. So at first I'm using Sariscape Sentinel-1 opening tool. From inside the Sariscape, go to import data, and inside the import data, there you can find the single sensor here. Expand the single sensor and go to the Sentinel-1. You can see all of the sensor here. Among them, select over the Sentinel-1 here. Okay, you can choose the input file that we have just downloaded. I just select it, and you have to upload your area of the interest, but at this point I do not have the area of the interest. So I am opening my Google Earth Pro here, and I am zooming over the Kathmandu region, and okay, let's move the globe to the Kathmandu and zoom over my area of the interest. Okay, and here you can, and I using the polygon tool, I am drawing my rectangle. And I rename this polygon as a Kathmandu. Okay, hit over the OK button, and right click over the Kathmandu here, and click over the save place as, and save the place inside the download section. And instead of KMZ, I am using it. I am saving it over it is the KML file. So inside the optional file, okay, inside the optional file, go to the folder and select the kathmandu.kml. we can't process the whole imagery, so we have to upload our area of the interest. So go to the output file and give our own output folder here, and I am creating a new folder according to my date, and suffix is a persistence PS. Okay, click over the PS and select okay, and hit over the right button and click over the execute, and wait until it will open our Sentinel-1 imagery. It will take some time. You can see completed here, and you can see the actual SAR imagery. It's not georeference it, so that you can see in the different orientation and the different direction. But For this video I have yes, okay, go to the PS and you can see all of the different files that is generated after opening of the Sentinel-1 imagery. And for this video I have already downloaded 100 plus imagery of each of the year and keep inside my on directory here. Okay, and you can see inside the Kathmandu displacement you can see all of the year here, and some of the output folder also here. I am going to delete it. Okay, you can see the folders that have name based on the year, and I keep all of the Sentinel imagery that is available of this region for whole 2015 here. All of them are descending orbit, and I have downloaded all of the imagery of the 2016, 17, 18, 19, 20, 21. Yes, all of the years, all of the imagery that is available in this region, because you need at least 40 imagery. I am using here 103 imagery, but I think it will take more time to process, so I will take only the sample here. So our importing data step is completed. Yes, we can go to the interferometric scattering here, and we are using persistent scattering. And okay, yes, and okay, we are opening our data here and go to the yes, we are using only the BB band. Yes, we can mix those BB and the VH band because they have their own significance in their own places, right? So we can mix BB and VH band, so I am only selecting the BB band. And okay, go to the open folder, and in similar way I am opening all of the data of 2016, and similarly for the 2017 and 2018. Okay, the process will take much time, so for video I'm using only 2015, 16, 17, 18 4-year data set, and I am creating the another folder. Here is the data is already present, so I am creating the new folder here and rename the folder is my date along with PS output. Okay, select the folder and hit open. Yes, file name, as I'm going to give this as a connection graph, no, Kathmandu. Select open and hit over the execute button. It will take some time, and wait until the process get completed. Yes, and it will automatically estimate the baseline data from all using those base data and the slaves data, and it will create the graphs that will show the relation of the slave data with the base data, and it will also measure the baseline those perpendicular baseline distance from the of these slip data from the base data, and it will also remove it will also suggest to remove if the baseline distance is so high. So the data, yes, our connection graph is completed, and you can see the time position plot and the time baseline plot, and you can see the different time capturing time of each of the slate data with respect to the base data, and the perpendicular baseline distance of each of the slip data with respect to the base data. And yes, our connection graph is completed, and now we are moving towards the interferometric processing. Here we created the interferogram of each of the slip data based on the base data, and yes, just open the folder. We are keep all these all these connection graph output from the inside this folder and select the auxiliary file, and we are using this auxiliary file all the time. Yes, at this time we need a DEM data set, so we didn't have the DEM of the same area, so but the NB facilitate us to download in the real time from the internet. So I'm downloading from the internet of the data set. Yes, I'm downloading the LOS World 3 data set. You can download any of the data set that is mentioned here. So here you can see the DEM along with the SAR data set, and in the paragraph the paragraph is kept default. So if you have knowledge about the azimuth look and the range look, all of the information you can change, and you can change the sensor if you know the sensor type. But if you do not have the knowledge, you can keep the default parameters. It will create the best result for you. Okay, just to wait for some minute. The interferometric the creation of the interferometric process takes time. So yes, just wait a minute. Yeah, the process is completed here, and our PS is completed, and we move towards the EPS. Close it, and okay, and if you go to the output folder here, okay, let's move to the output folder here. Kathmandu PS processing connection graph completed, and the interferometric stacking completed. You can see all of these data inside the work folder and the connection graph folder, all of this folder. But what it is linked with the auxiliary.sml file. So okay, let's go to the inversion first step, and okay, select the auxiliary.sml file, and no need to change the parameter. Okay, our first step is going to be completed very soon. Yes, it's completed now. Now we move to the second step. Complete the second step. Yeah, one thing is it's not very difficult to process the Sentinel data here in the SAR script, but you have to understand actual theory, and at last we are going to do a geocoding here, and by again selecting that SML file that is generated from the second phase unwrapping, Kathmandu data processing, that SML file, auxiliary.sml file, and option. Yes, at this time we are using same process to download the DEM data, and yes, and same DEM data will get downloaded here. If you have the high resolution DEM of the same area, you can give the path of the same data to download to upload here, so it will create the more accurate interferograms, or yes, interferograms and the results. Yes. Also the geocoding is completed. Our process is completed here. Yes, our process is completed, almost completed. Okay, let's see. It will cut off all of the those persistent scatter which is not so much stable here at this point, and give us the shape file with the displacement data set. Okay, let's close the geocoding here. Okay, and move to the folder where our data is going to, and click going inside the geocoding. You can see Kathmandu persistent scattering 75 is the threshold, right? And it will create all of the images, all of the points that have the displacement that has the stabilization value more than 75%, right? And if yes, and you can see the all of the displacement data or points of points over the DEM area. And if you go to the time series analyzer and go to the vector, and you can give the color, and you can see the displacement that is in the from the -20 -17 mm to +20 mm, almost 21 mm in this region. And if we can plot this value in the time plot time series, time series plotter. And yes, we can okay, let's see the result, right? They have the 0 initially, and move something 1 point is stabilized to 0, and 1 point is moving in the positive, as one is uplifting, and the blue one is depressing, and the red one is uplifting here. And that's for all. Thank you.